Welcome to the Laboratory, a video series brought to you by Miracles Innovation Labs.
Today I will be discussing custom vision AI object detection using Azure Service. Myself, Rongal Sandeep Kumar, working as a research associate in machine learning in Miracle Software Systems. Here is the agenda. I will talk about introduction to deep learning and also about Azure Custom Vision and then object detection using custom vision and also the use case of object detection and then type of model used for object detection for this solution architecture and finally live demo. Now introduction to deep learning. Deep learning is a subset of artificial intelligence, relies on neural network inspired by the structure of human brain. These networks, which are made up of interconnected layers of nodes or neurons, process the data using weighted computations. The use of deep architectures containing several hidden layers between input and output layers. It is the primary characteristic feature of deep learning, allowing it to automatically extract detailed features from raw data without the need of manual feature engineering. This technology is especially effective in domains such as computer vision, where convolutional neural networks succeed at tasks such as image identification and natural language processing, where models such as PET and GPT have revolutionized into language understanding and generation. Deep learning, although its enormous potential, has problems such as the requirement for significant data and processing resources, the risk of overfitting, and the interpretability of complicated models. Ongoing research in areas such as reinforcement learning and explainable AI is poised to broaden its compatibilities, promising robots that can understand, reason, and make judgments in ways similar to human intelligence. Deep learning services are also important in modern AI applications, automating work in a variety of domains ranging from digital assistants to self driving cars, and improving automation for analytical and physical tasks, making it a transformational force in the AI environment. Now let's discuss about introduction to Azure Custom Vision. Azure Custom Vision is a cloud-based service from Microsoft that simplifies AI-driven image recognition by allowing enterprises to build customized models for accurate object identification. It serves customers of diverse levels of skills and offers applications in areas such as retail, manufacturing, healthcare, and automotive, etc. Its user-friendly interface makes developing models easier by enabling customization with user datasets and effective data labeling. Advanced machine learning based training and optimization improve model performance, while REST API integration ensures practical use. Scalability in Azure accommodates shifting needs. The real time image processing is appropriate for applications such as content moderation and security surveillance. The application adapts when datasets update utilizing continuous learning. In short, Azure Custom Vision enables business to leverage computer vision, improving operations, customer experience, and decision making processes through the use of accessible AI driven image recognition technology. Now we are going to talk about object detection using custom vision. Object detection with custom vision is a powerful use of Microsoft's Azure Custom Vision service that uses deep learning to recognize objects in real time and with high accuracy. This technology specializes at identifying and allocating items within photos or video streams, making it useful in areas such as inventory management, security, surveillance, and automation. Customized model creation, streamlined data labeling, iterative training for optimization, seamless integration via REST APIs, real-time detection capabilities, scalability on Azure's cloud infrastructure, adaptability through continuous learning, and cross-platform compatibility are among the key features. Especially, it enables organizations to use AI-driven object recognition to streamline operations, improve security, improve customer experiences, and automate tasks that rely on item identification and position within visual data. Now we are going to talk about object detection use cases. Object detection, a critical aspect of computer vision and AI, has several applications in a variety of industries. It simplifies inventory management and self monitoring in retail. It facilitates safe navigation for autonomous vehicles by detecting challenges. It is used in security surveillance to detect threats, and it is used in healthcare to detect tumors early. It is used in manufacturing for quality control, disaster response by drones, and visual research by e-commerce platforms. Object detection is also used in traffic management, document processing, animal conservation, sports analytics, and AR/VR. It also helps with smart agriculture, food quality management, garbage sorting, and other tasks. Object detection is a transformational technology and automates operations, improves safety, and drives innovation across industries. Now we are going to discuss about model used in object detection. Object detection is a critical aspect of computer vision that is inextricably linked with image identification and image segmentation, allowing for thorough sense analysis in images and videos. Its major goal is to scan digital images or real-world events quickly, identify specific items, separate them, and rigorously analyze their fundamental qualities for real-time forecasts. You only look once. YOLO is one of the most well-known model designs and methods in the field of object identification. YOLO is well known and frequently appears as the first result in Google researches for object identification algorithms, demonstrating its popularity and effectiveness in the industry. This is the solution architecture. First, we have to gather the images and then we have to ingest the data into the Azure Custom Vision AI object detection, which is present in Azure service. And then we have to label the data and then model training. It means we have to train the data which are labeled the images and then we have to do predictions and then we have to publish this model after training. I have used form recognizer, which is used for extracting text from the images, and I have combined those using Python. Here's the output, and then finally, live demo of Azure Custom Vision AI object detection. Hi everyone, coming to live demo. First, we have to create a project in Custom Vision AI in Azure. I have created two projects. One is for detecting interior parts of a car, and other is for detecting P&ID symbols. If you want to create a new project, we have to click on this button. After clicking on this button, you will get a pop-up like this. We have to enter the name of the project and then description and then resource. The description is optional. If the resource name is not present, we have to create a new resource and then select the object direction in project type and then any of these in domains based on your project scenario. After entering all the details, you will get a chance to create project. The project will be created. Now I am entering into symbol detection because I have already created this. After creating the new project, the page will be open like this. The images can be added from here or from here. The image size should not be exceed more than 6 MB and the supported formats of images are JPG, PNG and BMP. Now I am adding the image from here. The image is uploaded into untagged images because the objects are not labeled. If the objects are labeled, those will be present in tagged. These are labeled. Any of the object is not labeled, so it is present in untagged. If the object is labeled, I am keeping it as STA for name convention and labeling names are present in right side in my object. If you want to unlabel, you can deselect here. Now I have labeled one object in this image. So it will be entered into tagged images. It is not present in untagged. You can see that just now I have labeled this object as STA and this image is entered into tagged. If I have removed this label, then it will be entered into untagged. After labeling all the images, we have to train the model to detect objects. To train, we have to select this button. The training is of two types. One is quick training and another is advanced training. Quick training takes 1 hour of time and advanced training takes 1 hour to 96 hours of time. By clicking this button, the quick training will take place of. Or if you want to train in advanced training, by selecting this, you can change time for training based on your budget from 1 hour to 96 hours. And then you have to click on this button, train. The model will be trained. After training the model, we can see the metrics of the model by clicking the performance. You can see the precision, recall, and mean average precision. Precision. This number will tell you if a tag is predicted by your model, how likely is that to be right. And this number will tell you out of the tags which should be predicted correctly and what percentage did your model correctly find. And this number will tell you the overall object detector performance across all tags. And then we can do quick test for the model. The test can be done by using two methods. One is using image URL and another is using local files. If you want to use image URL, you have to enter the image URL at here and then we have to press this button. We will get the predicted objects at here. Based on the threshold value, we can see the results. If we increase the threshold value, the results will be decreased. If you want to use local file, you have to click this button. Then the image will be tested at here. This is also be done by using threshold value only. After quick test, the predictions will be stored in predictions. If you want to use this model locally, you have to publish. To publish, you have to go to performance and then you have to click on the publish button. Then you will get prediction URL. The predictions can be done on two methods. One is image URL and other is local files. I have published and the prediction URLs are like this. This is for image URL and this is for local files. After publishing, I am using this image URL for testing locally. We can see the results at here. Thank you.
Thank you for watching The Laboratory, a video series brought to you by Miracles Innovation Labs. For more on innovation, please visit miraclesoft.com/thelabs.